Hello students, this is the second assignment in week April 27th. This is actually Unit 4. This would have been our Unit 4 first lesson, and this is the handout, and there are 20 problems on your handout. You should have at least downloaded that so you could look at it. You can, if you printed it, that's great. You can work along with me. You might not feel like you have enough room though on the handout, so you might actually just want to work these on loose leaf paper anyway. 20 problems, we're going to work through all of them. I just want to remind you that we've already done the lesson video for this particular lesson. It's on simplifying, multiplying, and dividing rational expressions. Rational expressions are fractions with polynomials in them. And wanted to remind you also that we found the domain restrictions. We found what the extraneous roots is another word that we could use for it, where we would set the factors in the denominator equal to 0 and would say, okay, this equals this as long as x does not equal these numbers. We're not going to do all that in this handout. It's going to be more important later for our next lesson on rational functions. So I just want you to remember that there are values for each of the variables that wouldn't work. And what that means is when you graph that function, these numbers at these x values, there would be no data on the graph. So it would be like an open circle. So anyway, we're not going to do that on this worksheet because there's 20 problems and I really want to get through them within like 45 minutes. And so I'm not going to talk about the extraneous roots as I solve each one or as I evaluate each one or simplify, but just want you to remember that we did do that in that lesson video. So I'm going to just talk to you about the difference between numbers 1 and 2. Numbers 1 through 6, the directions are to simplify the expressions. So there's no multiplication or division of the actual fractions, but we do want to look at them a little bit differently depending on what's going on in the fraction. So I want to show you number 1. You see there's a term in the numerator and there's a term in the denominator. There's actually not, we wouldn't really call it an expression. There's no plus or minus. Number 2, however, if you look, you see there's a plus between these two terms. So that there's actually a binomial and a binomial in the numerator and denominator. So when you see something like this, what we can't do is we can't go ahead and simplify or cancel like the 7 and the 28 or the n squared and the n squared. We have to factor these first. So on number 1, though, there's no factoring to be done because it's just one term in each, in the numerator and denominator. So we just go ahead and start simplifying when we see something like this. When we see something like a binomial, or let's see, here's a trinomial in the numerator, we have to factor first. So factoring is our first step in the simplifying. Let's go back to number 1. So on number 1, we are going to just start canceling stuff out because these two terms don't have any pluses or minuses between terms in the numerator and denominator. So let's go ahead and look at the coefficients and see what we can divide by there. We can divide both of these by 8. So that's the greatest common factor of 16 and 24. So let's go ahead and do that first. And then we'll look at the variables. So 16 divided by 8 is 2, and 24 divided by 8 is 3. Okay, so now let's look at the m squared and the m to the 7th. If you need to, you can just over to the side, make a new fraction. So this is 2 m's and this is 7 m's. This is the same as m squared divided by m to the 7th. If you need to do this, there's nothing wrong with that. So then what you do is you just write them out as, just a series of variables, and then you can cancel them in pairs. So each of the m's in the numerator, I can cancel with one of the m's in the denominator. The thing that I usually look at is I look at whatever the smallest one is, like if the m squared has the smallest exponent, and I'll say, okay, these 2 m's are going to cancel out 2 of these m's. So I would have 5 m's left. So this is a 1 up here, and then this is m to the 5th. I don't need to put this 1 over here. I've already got a 2. If I didn't have anything, I'd put the 1. But I've already got a 2 here, so I don't need to write 2 times 1 or anything. Just leave that. And then I bring this m to the 5th over here with the 3. So this is our simplified answer. Okay, number 2, again, we have a binomial in the numerator and a binomial in the denominator. That means we need to see if we can factor something before we start to cancel anything out. Now, numerator, I see that there is a GCF of n. They both have n in them. And the GCF, if you have the same variable in both terms, the GCF of that is going to be the variable with the lowest exponent. So the n to the first is the GCF. It's the greatest common factor. So I'm going to pull out that n to the first. And then I'm going to just divide each of these by n. N squared divided by n is n. And 7n divided by n is 7. So this is factored. This one I can take out, from the coefficients, I can take out a 4. And then I can take out an n also because they have an n in common. This divided by this is n, and 28n divided by 4n is going to be 7. So now I have some couple things I can cancel. Anytime you have a factor in common, even if there's a plus or minus between it, if it's exactly the same thing, numerator and denominator, cancel them out. So I can cancel out the n plus 7. I can also cancel out these n's right here. If you end up with nothing left in the numerator, that's not a 0. Remember, that's a 1. And then my denominator, the only thing that's left is a 4. So this simplified is 1/4. Number 3, I need to factor first. I have a trinomial in the numerator, so I need to factor that. And I can factor that into 2 binomials. Remember, your method for doing that is look at the negative 24 and the negative 10. I need a factor pair for negative 24 that when I combine them I get negative 10, and I'll just tell you it's going to be x minus 12 and x plus 2. And then I have an x plus 2 in the denominator. It might help you to put those in parentheses. But now I have an x plus 2 in the numerator and denominator that I can cancel out. Can't do that before you factor. So factor first. Now, I'm left with a 1 in the denominator, which I don't need to write. So my answer, my simplified answer, is x minus 12. Don't forget that if we were going to do this, if we were graphing this, we would want to know what the extraneous roots were, and we would set up the x plus 2 equal to 0. So x would not be able to equal negative 2. So this right here equals this as long as x doesn't equal negative 2. And number 4, the numerator is a difference of 2 squares. 1 is a perfect square, 9 is a perfect square, and w squared is also a perfect square. So I can break this up into 2 binomials. 1 plus 3w and 1 minus 3w. And then I can take out the greatest common factor in the denominator. If I were to take out just a 4, let's look at what that would look like. That would give me 3w minus 1. Now remember, I talked to you about if there's a negative or if there's a minus symbol, but the terms are reversed, I need to take out a negative 1. So here's what I'm going to do. Down on the bottom, I'm going to take out a negative 4 instead. And so 12w divided by negative 4 is negative 3w. Negative 4 divided by negative 4 is positive 1. Now, negative 3w plus 1 is the same as 1 minus 3w. So if I just do it like that in the first place, I end up with a factor that I can cancel out. And this is how I can write my answer. I want you to understand too, though, that a negative can go in the numerator or in the denominator. So you might see something like this. Or you could see this distributed in. So you could see a negative 1 minus 3w over 4. So any of these would be a correct answer. You just need to understand that, because if you see a multiple choice answer on an exam, you need to be able to recognize that this equals this equals this. So I'm not a person who likes to skip steps. I like to write everything out just so I know that I keep everything kind of straight and keep it together. So in this number 5, first thing I'm going to do is look for greatest common factors, and then I'm going to see if I can factor this in any other way. So numerator greatest common factor is going to be 4a, and that's going to leave me with a minus 9 in parentheses. And then the denominator also, I'm looking at it thinking, oh my goodness, there probably is another way I could factor that, but I'm going to look for greatest common factor first. I think that's going to make it easier to deal with. So my lowest exponent on my variables is a 2, so I know I'm going to have an a squared as part of that greatest common factor. And then all of these are even numbers, so I'm also going to take out a 2. So I'm going to take out a 2a squared. This divided by 2a squared is a squared. And then that's going to be minus 12a, and that will be plus, 27, right? So I have a little more work to do as far as factoring because I've still got a trinomial right here that I could factor again. So I'm going to rewrite everything. Again, I just like to make sure I kind of keep everything in the right place. I still have that 2a squared. And then I'm going to write this as the product of two binomials, and those are going to be a minus 3 and a minus 9. So now I can start canceling. I've got a minus 9s I can cross out. I've got a 2 and a 4 that I could divide both of those by 2. And then I can divide these by a. So that's going to be 1 and that's going to be a. So let's see what I have left. In the numerator, I just have a 2. In the denominator, I have a times a minus 3, and I can leave it just like that. I don't have to multiply that through or anything. All right, so number 6, I would like for you to at least factor the numerator, and then for the denominator, you're going to have to factor this into two binomials. You're going to have to split that middle term. So you're going to multiply the 5 times the negative 24 and then look at the negative 26. If you can't do that, then you can follow along with me, but pause your video and see if you can at least factor the y squared minus 36. So you should have recognized this is a difference of two squares. And then down here on the bottom, I would have to, again, multiply the 5 times the negative 24, find a factor pair that combines to get 26. I'm going to go ahead and just tell you what this one is just to save some time. This is going to be 5y plus 4 and y minus 6. And if you're not sure how to do this, you can go back and watch the video on factoring. The factoring trinomials where a is greater than 1 would be what you would want to watch. So now I have a y minus 6 I can cancel, and I'm left with y plus 6 over 5y plus 4. Okay, so that was all of our simplifying. The next ones we're going to do are multiplying. So when you have two expressions like this, there's no pluses or minuses, there's no binomials in the numerators or denominators, so you just start canceling stuff. You could write this as like one big problem. So you could write all of this together like this. Okay, so you can write it like that, and you can just start canceling stuff. I've read directions before that say, oh, multiply the coefficients, multiply everything out, and then cancel. To me, that's harder. I would rather do the coefficients like this because they're easier to deal with. They're smaller numbers, and then you can multiply all the variables out if you want to, but I'd rather deal with the coefficients first, just like this, because I'm seeing a 32 and an 8 that I can simplify. I divide both of those by 8, so that gets rid of that 8, and that changes that to a 4. And then I'm also seeing a 15 and a 5. I can divide both of those by 5, gets rid of that 5, changes that to a 3. At this point, what I can do, and I'm going to show you two different ways to do this. What I can do is go ahead and multiply everything out. 4 times 3 is 12. X cubed, and then y times y cubed is y to the 4th. Okay, and then on the bottom I have a 1, and then I have an x cubed and a y to the 6th. Remember, you add those exponents together when you multiply. So now I can cancel out the x cubed, and the y to the 4th would cancel out 4 of these y's, which would leave me with 2 y's. So my answer would be 12 over y squared. Another way I could have done it is just start looking at my variables right here. So I could say, okay, 3 of these cancel out 3 of these, so that leaves me with 1. And then I've got x cubed here, and I've got x to the first and x squared. So I know that those are all x cubed, because that would be x cubed. So that would get rid of all my variables as well. Oh, I've got one more y, sorry, y and y right there. So that leaves y squared on the bottom, and then I've got that 4 times 3. This gets a little messy. Might be easier to do it like this. Go ahead and simplify your coefficients, and then multiply out your variables. You won't see a whole lot like this on this this worksheet. Most of them have binomials and trinomials that we have to factor first anyway. But that's how I would recommend doing that, instead of multiplying 32 times 15 and then 5 times 8 and then trying to simplify that. So number 8, we need to do some factoring first. We need to rewrite this whole thing. So I'm going to just put an equals here, and then I'm going to factor this trinomial into m minus 2, m minus 4. And then this, I'm going to take out the GCF of 2. That's going to give me m minus 1. And then the 10 can't be factored. The m minus 4 can't be factored. But it can be canceled with this m minus 4. But I think that's the only thing. Oh, the 10 and the 2, sorry. 10 and the 2 can be divided by 2. That's a 5. So then my numerator is 5 times m minus 2. Because remember, we're multiplying. This could really be written as one big expression, honestly. And then my denominator is m minus 1. So for number 9, I would encourage you to pause your video and see if you can work this one. I will tell you that since these are all binomials, there's no trinomials here, all you're doing is taking the greatest common factor out of each expression and then canceling factors. So I want you to pause your video and see if you can get this one. So this one did end up being a lot of things that I could cancel out. For 28n plus 40, I factored out a 4 and got 7n plus 10 in parentheses. Down here, I got 5 7n plus 10, so those canceled out. And then on the second fraction, I took out greatest common factors and was able to cancel out the n plus 2. I did the 4 and the 8, and then I did the 12 and the 2 that was left over. So my answer ended up just being 6/5. No variables left over. For number 10, I would again encourage you to pause your video. Understand that in this first expression, there's nothing that can be factored. However, I see this 9 minus p, and I'm thinking I might switch that around. I might take a -1 out of that and change that to p minus 9, because I kind of have a feeling that I'm going to have a p minus 9 somewhere that I can cancel out. That's just me. And then this one can be factored into 2 binomials, and then this one you'll take out the greatest common factor. So I want you to try this one and then come back and see if you got it. So this is what it looks like after you factor it right here. And I did get a p minus 9 when I factored this trinomial. So now I can cancel out the p minus 9s, the p plus 4s, and I believe that's it. I'm going to move this negative up here, and I'm going to write it -1 p plus 10. The reason is a lot of times, like on IXLs and everything, you will need to put that negative in the numerator. So this would be acceptable for me, but IXL might want to see you write -p minus 10 over 4p. Remember, you can't cancel out the p and the p here, because this is a binomial. So it might help to put binomials in parentheses so you can see what you can cancel and what you can't. So again, for me, this would be acceptable, but you might also see something like this on an exam. So I want you to try this one too. I'm going to give you a hint. The first numerator will end up being 2 binomials. This one's going to stay like it is. Second numerator, you're going to take out a GCF, and then this denominator is also going to be 2 binomials. See if you can factor them and then come back. So I had made the variable in the first one a y. By mistake, it should have been a v. So yeah, all the variables are v's. So this was the difference of 2 squares. This one I pulled out the greatest common factor of 4v, and then this one stayed the same. The second denominator factored to v plus 7v minus 6, so I can start marking stuff out. I can do the 4 and the 20. And then I can also do this v and this v cubed. So this 1v would cancel out one of these, leaving me with v squared. So let's see, what do we have left? We have v minus 7 in the numerator and 5v squared in the denominator. For number 12, I'm going to work this one out completely with you. The first rational expression, it stays the same. Nothing can be factored there. I'm going to look at this denominator real quick. I'm going to take out a -1, just a negative, and change this around. Remember, I told you in the lesson video you can do that. The reason I'm going to do that is because I figure if I'm going to have anything I can cancel, it's going to be a variable first and then the constant. So I always, if I see something like this where I've got a minus and I've got the variable in the second term, I like to go ahead and take out that negative and switch them around. So let's see, I'm going to go ahead and factor this denominator first, and then we'll talk about this numerator right here. So I've got my negative, I just need to keep that. This is difference of two squares, so this is going to be 2n plus 3 and 2n minus 3. Okay, all right, so this one right here, I'm going to multiply the 2 times the 3. This is called the AC method. Multiply the 2 times the 3, that gives me a 6, and then I've also got a 5. I need a factor pair for 6 that when I combine it is 5. Of course, it's 2 and 3. Positive 2, positive 3. Now, the next thing I need to do, I can't go ahead and factor this yet. I have to rewrite this and split the middle term. So I'm going to do that down here, 2n squared plus 2n plus 3n plus 3. So what I did was instead of writing 5n, I changed it to 2n plus 3n. So this expression actually equals this expression. I didn't change the value of it or anything. I just rewrote the 5n as this 2n plus 3n. So now I'm going to split this down the middle, and I'm going to take out a GCF on each side. 2n, n plus 1. Whoops, sorry. I should say n plus 1. And then this is I'm going to take out a 3 over here, and I have an n plus 1. If you get these the same, you know you did something right. That's your first factor. And I've done this in another video. I'm not going to go through it in very much detail. So this factors to n plus 1 times 2n plus 3. Also, I got some stuff to cancel out, so I kind of figure, okay, I did something right here. We'll cancel out the n plus 1s and the 2n plus 3. And the 2n minus 3. So guess what my answer is? In the numerator, I have a 1 left. In the denominator, I have a -1 left. Well, 1 divided by -1 just equals -1. So this whole thing right here equals -1. But remember, that's only if when you set these up equal to 0, all these factors, you have to set them up equal to 0. So n could not be -1, n could not be what, -3/2 or +3/2. So just keep that in mind as we do these. We're not going through all that to save time. Okay, number 13. Looks like these are binomials, so all I really could do is take out GCFs. So I want you to try this one and go ahead and solve it all the way through and see what you get. Okay, so I didn't mark anything out because I wanted you to be able to see this, but this is what I did. I took out a 6k from here and took out that greatest common factor. The 6k here stays the same. The 6 stays the same. Here, again, I see I've got my variable is in the second term, so I took out a negative number. And so if I take out a -9 here, I get -9 plus 2k, which is the same as 2k minus 9, so I can switch that around. So I did that, and then I can cancel those. I can cancel the 6k there, and I just wrote 6 over -9 here, but that can also be simplified to -2/3. So this is your simplified answer. Okay, number 14, I'm not going through how to factor these trinomials. If you want to try it, pause your video and come back, you can. I'm going to go ahead and work through it. This first numerator factors to 2c plus 9 times 3c minus 7. This denominator factors to 2c minus 1 times 3c minus 7. This numerator factors to 2c minus 1 times c minus 4. And then this one we're going to take out a GCF of 6, 2c plus 9. So let's look for some stuff we can cancel. This 2c plus 9 here and here, 2c minus 1, 3c minus 7. What have I got left? I've got c minus 4 in the numerator and 6 in the denominator. Okay, so I think that's all of our multiplication. The next 6 problems are division. So I want to remind you of 2 things. Division, we have to change this to multiplication and flip this second fraction over. I also want to remind you that when you're looking for those extraneous roots, those restrictions, you're going to look at this denominator and both numerator and denominator here. If you don't remember why, go back and watch the video lesson. So let's rewrite this. First fraction stays the same. This changes to times, and then you take the denominator and make it the numerator, and vice versa. So I don't have any binomials or trinomials. I don't need to factor anything. I just need to start canceling stuff. The 14 and the 7 can cancel. This changes to a 1 and this changes to a 2. I'm going to mark those out really well so we're not confused. The 3 and the 18, I can also cancel those. That's a 1 and that's a 6. I can do this m fourth with this m to the first. This would be an m cubed, and this goes away. If I do the m to the fifth and the m squared, not a big deal. This becomes an m cubed. I can't cancel this m cubed and this m cubed because they're both in the numerator. I end up with nothing in the denominator but 1. So I can just multiply everything in the numerator that I have left. 2 times 6 is 12. M cubed times m cubed is m to the 6th. My denominator was 1. I don't need to write that. So this is actually my answer. Now, one thing I would allow you to skip steps on is if you're able to factor as you rewrite it, that's fine. Like when you rewrite this expression right here, if you want to go ahead and factor this trinomial, you can do that. That probably wouldn't be a problem. That's how that factors. You got your 6x, then change that to times. Remember that your 2 is going to go here. And then we can go ahead and factor this and take out a GCF. Okay, so now I can cancel stuff. The 2's cancel. The x minus 7 cancels, and that's it. So my answer is x plus 4 over 6x. So this divisor is not written as a fraction, but I can write it as a fraction. I can write anything as a fraction by putting it over 1. So that makes it easier to flip it over if I think about it that way. So let's go ahead and rewrite as a multiplication problem. And I'm going to go ahead and factor these as I go. I'm going to take out a 2a. That's going to be a plus 7. This stays the same. And remember the 1 goes here. And the 10a plus 70, I'm going to take out a 10. Then I can cancel the a plus 7. I can cancel this a and this a squared. The 2 and the 8. And I believe that's it. The only thing I have left in the numerator is a 1. I'm going to go ahead and multiply the 4 times the 10. So that is our answer. Okay, we have 3 more. There are several things in this problem I want you to pay attention to. First of all, remember you're going to rewrite it as a multiplication problem. So I'm going to go ahead and put that there. I know that this 6 is going to go up here, and this I'm going to go ahead and factor as I rewrite it. I have an expression here where I have the variable second, and it's a negative. So I would go ahead and take out a negative 1 and rewrite that as h squared minus 1. This is a difference of 2 squares, so it still needs to be, I'm going to write it right here. There, I'm just going to write it like that. Get rid of that right there. So what I would do is this difference of two squares. This you can take out a GCF. So you could go ahead and write that down here. And then factor that as you write it over here. So I want you to pause your video and try to at least factor all this stuff and get it rewritten as a multiplication problem, and then come back and see if you got that. Okay, so this is how everything factored out. I don't lose your negative over here where you took that -1 out, so you still got that negative there. This is h plus 1, h minus 1, difference of two squares. I pulled out the 2 down here, and then I factored this to h minus 6, h plus 1. Flip this second fraction, the 6 goes here, and I took out a 2 here and got h minus 1. So now I can cancel some stuff. I can cancel an h plus 1 there and h minus 1. I can do the 6 and the 2. That's going to be a 3 there. I think that's it. Don't forget about the negative here. It needs to go with the 3. So my numerator is a -3. My denominator is 2 times h minus 6, and you can leave that like that. You don't have to multiply that 2 in. All right, so this next one, we've got 2 left. This is number 19. Need to rewrite it as multiplication, but I'm going to look at my numerators and denominators. I have a trinomial right here that has a 4, an 8, and a 4. So I know I can take a 4 out of that. So here's what I'm going to do. I'm going to go ahead and I'm just going to erase it. I'm going to erase it and rewrite it. And I'm going to take out that 4, and that would have been r squared. Let me make sure it was a plus, yeah, plus 8r, so plus 2r plus 1. Now what I can do is as I rewrite everything, I can go ahead and factor that. Remember, that's going to be down here, so that's going to be 4 and then 2 binomials there. I'll take out a greatest common factor here, and everything else, I'll take out a greatest common factor here, and this stays the same. So go ahead and factor it and see if you, and then come back. Okay, so this is what I got right here when I factored everything. I have an r plus 1 here and here, and I also have another one in the numerator and denominator. I'm going to cancel the 4 and the 12. That makes that a 3. So I think that's it. That's everything I can cancel out. 2 times 3 is 6. And the only thing left in the denominator is r plus 2. Okay, number 20, this is our last one. This is 3 different expressions. One of them is division. I'm going to go ahead and make this a fraction now. And then this one's multiplication. So I would like to just rewrite the whole thing so I don't get anything mixed up. So I'm going to change this to division. This is going to be 1 over 5x minus 1. And then this one stays times. All right, so what can be factored? The only thing that can be factored is this right here. So instead of rewriting the whole thing, I'm going to erase it and go ahead and factor it. Take out that 4, and that would be 5x minus 1. So let's see what I can, what can I cancel out? I can cancel out the 5x plus 1, excuse me, 5x minus 1. I can do this x and this x squared. And then I can do the 4 and the 8. Let's see, is that everything? Seems like there's one more thing. Oh, the 6 and the 2. So that becomes a 1 and that becomes a 3. And so what's left in the numerator? Just a 3. And in the denominator, I have a 5 and an x. And that's it. So we did simplifying rational expressions. We multiplied them and we divided them. And just need to remember that when we divide, we need to change it to times and then flip the second fraction. We also need to remember that there are extraneous roots. We just didn't go through any of those today in the interest of time. But what you would do is multiplication and simplification. You take your factored denominators, set those up equal to 0, and that'll give you those excluded values. On division, you use the denominator of the first fraction and the numerator and denominator of the second fraction. And I think that's it. Let me know if you have any questions.